I've been involved with climate change issues for several years. This has involved attending lectures and workshops and assisting in running seminars for 6 years organised by the Department of Social Anthropology, Sustainable Engineering and the Faculty of Education. I also participated in good energy policy seminars and initiated a series of projects on environmental education for primary school children that have been running for several years and have developed a global dimension with cross-communication between the UK, Italy, Nepal, Mexico, Alaska, South Africa and Mongolia. I'm also a regular participant of political ecology seminars at the Geography Department, Cambridge University, after attending the undergraduate political ecology course and an environmental justice course. I was a regular visitor to China, particularly Tibet and other Himalayan areas, including Nepal, Bhutan, Sikkim and northern India, as an associate member of the Mongolia and Inner-Asia Studies Unit at Cambridge. All these areas are affected by climate change. However, I don't remember that the climate change effect on rivers was particularly highlighted at these events or on my travels. There was a lot of discussion of the effect on sea levels and snowmelt, but very little specifically about rivers. This talk therefore focuses on the effect of climate change on rivers, but initially particularly on our local chalk streams. I first will give you an introduction to chalk streams and the issues facing them from abstraction and climate change. I then talk more about the effects of climate change on streams and rivers and what we could do to mitigate the effects. I'm a committee member for Cam Valley Forum, a local group concerned to preserve our chalk streams, and a member of the River Mell Conservation Group, which has worked for the last 10 years to restore the River Mell running from the village of Melbourne to the River Ree, the tributary of the Cam, near Moulton. In England, and particularly in Cambridgeshire, we are blessed with a large number of these beautiful watercourses. There are about 210 in the world, 160 of which are in England, about 85%. Numbers vary in different sources depending on the definition of stream. In Cambridgeshire, the main river is, of course, the Cam, which you can see behind me. However, in order for this to be a healthy river, it is important that all the tributaries, stretching back to the smallest brooks, are also healthy with a good flow. These streams are particularly special because the water is filtered through soft chalk aquifer rock, forming the hills around the fens and low-lying parts of the county. They then emerge as very pure streams at the base of the hills, where they hit the hard chalk, producing a wonderfully mineral-rich gravel bed. One of the branches of the Cam, the Ree, arises at Ashwell Springs, venerated as a holy spot by the Romans, and probably earlier, as evidenced by the votive offerings to the gods. The other main branch is the Granter, arising in Widdington in Essex, which merges with the Ree at Byron's Pool near Grantchester. Another tributary, also called the Granter, runs from near Haverhill, joining the larger Granter south of Great Shelford. Another minor tributary is the Bourne Brook, which has its source near the village of Eltisley, 10 miles west of Cambridge, again joining the Cam at Byron's Pool. The water is at a constant temperature of 10 degrees centigrade all year long and is replete with minerals which make it an inviting environment for creatures at the bottom of the food chain. These then supply food for the special animals we have higher up, like the wonderful trout, otters, kingfishers and egrets. It also supplies a nutrient-rich environment for plants such as water crowfoot, an indicator of a healthy river, and water irises. These supply food for other animals. Of particular interest is the water vole, ratty in Wind in the Willows. This is an endangered species, but does well on healthy chalk streams. The streams have been used as recreational areas for centuries. I held some memory capturing events in Melbourne and Meldreth with elderly residents, and it was stimulating to hear the enthusiasm in their voices as they talked about spending time in the river as children. They used to build improvised rafts from old oil drums and float down from Melbourne to Meldreth. One participant said, "It was my playground. We would spend all day in and around it." Others talked of constructing swings to jump from bank to bank, often falling in, of course, causing much amusement. The river is still enjoyed for those who stroll along the footpath, and footfall has increased a lot since the start of the COVID lockdown. Children also paddle in it at access points, and some dam building occurs, but floating down it would no longer be possible because the height has dropped dramatically. So as well as no longer being the same kind of playground, the special biodiverse environment is now coming under severe threat. There has been a dramatic decline in the number of damselfly, dragonfly, stonefly, mayfly and caddisfly species on chalk streams in southern England. In order to retain a high level of biodiversity, there needs to be a reasonable level of water in the streams all year round, even during the driest periods. As important is the fact that this produces a steady flow. This is necessary to avoid the accumulation of silt on the base of the river, which stifles the invertebrate population, which is a source of food for the wide range of species. However, in several years recently, Cambridgeshire chalk streams have completely dried up. I visited 3 in 2009, in which there was no water at all. For Wilbraham, I was told this was the first time this had happened in 30 years. At the last survey, 2016, of the Granter and the Cam upstream of Cambridge City, it was classified as poor by the Environment Agency's own rating, and in need of remediation on up to 7 different counts. Biodiversity loss has already been remarked upon at many sites, including sites of special scientific interest. 9 Wells Springs, adjacent to the Addenbrooke's Biomedical Campus site, lost their SSSI status after a drought in 1976 that killed off 2 rare invertebrate species in the springs for which that site had been designated as of conservation value. This loss was entirely due to a catastrophic failure of flow. The flora of the River Cam and its wetlands around Cambridge has lost 35% of the total wetland species recorded over the past 3 centuries. In our rivers, such plants as the water crowfoots, starworts and pondweed species rooted on the stream bed are very sensitive to pollution, and the different species are each useful indicators of water quality. Many animals, as I've mentioned, invertebrate and vertebrate species, are all dependent through the food chain on the health of these river plants. Without the right plants and the right insects as food species, clean water fish like the brown trout will not survive. Our rivers and their margins should be rich in a great variety of water plants. Recently, the non-native floating pennywort has dominated areas on the Cam, thriving on the polluted, nutrient-rich waters to the exclusion of almost anything else in these areas. Our wetland habitats neighbouring the Cam are certainly in decline. The Cambridge milk parsley is now only holding on in 2 or 3 county conservation wetland sites. This is a great shame, as it is a local species but of national importance. When I first joined the River Mell Conservation Group 10 years ago, the River Mell was in a sorry state. It had been poorly managed for many years after the several mills and osier beds, willow plantations for baskets and cricket bats, along its course closed down and no one took responsibility for protecting the flow. There were also ill thought through dredging activities related to farming and other activities. The river was a murky, silty, sluggish ditch. Over 10 years, we have transformed it into a fast flowing stream with a shiny, gravelly, chalky base with flourishing wildlife. 2 summers ago, I counted 33 trout in the river, and we have regular visits from otters, herons and egrets. We also had several flourishing colonies of water voles. However, this year the river is now in a sorry state again. The flow has diminished, and earlier in the year I was able to walk across it in Wellington boots through thick mud. Normally I would have required waders. The base is again thick silt, and I haven't seen a trout this year. The burrows for the water voles were exposed because the level has dropped, and this makes them vulnerable to predators. Obviously the recent rain has helped, but we'll have to see what next summer brings. I was involved in the production of a film about the river, Waterlight. This is available at waterlightproject.org.uk. This is aimed to give people a feel for the beauty of the river, but also to indicate how it has been restored and now is under threat. I will show a 5-minute excerpt at the end of the talk. In 2019, the Environmental Agency reported that Cam was at its lowest level of flow since records began in 1949. An additional problem is that main sewage plants discharge into these chalk streams. As the level and flow drops, the pollutants become more concentrated. The Environmental Agency regularly records the water quality just downstream from the sewage discharge pipe on the Mell, and there is an increase in the levels. Related to this is the problem of chemicals leaching from plastic, which finds its way into watercourses as micropellets and microfibres. Bisphenol A has been shown to affect the reproductive cycle in aquatic animals and may also affect humans. The breakdown of the plastic and release of the chemicals is increased as temperatures rise on the banks where they are deposited with climate change. The main cause of the lowering of the flow and river heights is in abstraction for increased housing. However, another cause is considered to be climate change. Cam Valley Forum has recently published 2 documents which can be found on our website. These are the River Cam Manifesto and Let It Flow. Streams in other parts of the country and larger rivers like the Cam that don't stay at a constant temperature like chalk streams are even more affected by climate change warming. Higher temperatures cause more frequent algal blooms and reduce dissolved oxygen levels, both of which can cause fish kills and do significant harm to ecosystems. There is a lot of work being done on modelling of river temperatures to measure the potential effect of climate change. Cold water species such as salmon will be affected by the water temperature as it changes under the effect of climate change. This could have a significant effect on the salmon fishing industry and sport in Scotland. An additional issue is that in some cases there is more snowfall, which causes flash flooding when it melts. However, rising temperatures will cause more precipitation to fall as rain rather than snow, and will melt mountain snowpack earlier in the season, reducing the natural reservoir that has historically fed rivers throughout drier summer months. Due to changing glacial melt patterns, river courses can completely change, as happened with the Cashawulsh River in Canada. Internationally, snowmelt-dominated watersheds will also be affected, like the southern US and countries bordering on the Himalayas. As China controls much of the sources of water for Southeast Asia, this could have significant political consequences. Warmer temperatures will also increase evaporation from reservoirs and lakes, offsetting increases in precipitation in some regions and magnifying decreases in other areas. In Bolivia, the country's second largest lake has completely disappeared. A major study of 900 rivers published in the American Meteorological Society, AMS, Journal of Climate in 2009 concluded that flows into the oceans have decreased significantly over the past 50 years, with that trend predicted to continue. Another effect is increased carbon dioxide concentration in the water, which increases the acidity, which affects certain species. Also, increased carbon dioxide in the atmosphere means that plants generally are photosynthesizing more efficiently and therefore using less water. This can have contradictory effects depending on the landscape. In some circumstances, this is increasing river flows, producing flooding as the plants use less water. In other cases, river flows are falling because there are more plants using the water. Related to this, climate change will increase other nutrient levels in rivers, causing algal blooms. Toxic chemicals build up on warm roads during warm weather, and flash floods can quickly wash them into rivers or other watercourses as runoff, causing major pollution episodes, either chemical or thermal, sufficient to wipe out entire fish stocks from stretches of rivers. Greater rainfall intensity could lead to more suspended solids, sediments and other contaminants entering rivers, leading to more silting up. Cardiff University scientists suggest that climate change is hampering the recovery of Welsh rivers from acid rain. Wetter winters have led to greater acidification of upland streams, raising acid levels in the rivers they feed into and undermining efforts to reduce acid rain by cleaning up air pollution. Policy responses to climate change, such as the growth of biofuels or emission controls, will further impact freshwater quality. Going back to a local perspective, Cam Valley Forum believes that these problems are caused by over-abstraction and changes in the weather patterns, probably related to climate change effects. Cambridgeshire does naturally have low rainfall, East Anglia being one of the driest parts of England. Commonly there is 50 to 60 centimetres per annum. However, this varies annually, seasonally and episodically. At the extremes there can be large-scale droughts or massive downpours. Neither of these is good for the streams. Therefore, any change to the rainfall patterns has a significant effect on the state of chalk streams. For decades, Cambridgeshire had a mean rainfall of 56 centimetres, 22 inches. The mean over 60 years is substantially unaltered. However, there is now more variability, and this is predicted to increase. Winter rain is what is needed to restore the aquifers supplying the chalk streams. Summer rain is used up by plants or evaporates. Therefore, decreasing levels of the right kind of rain, not intermittent strong showers, will have an effect on the chalk streams. However, it is not just a lack of water that causes problems. The increase in extreme events and the increased variability in weather patterns have an effect. Heavy downpours, as experienced in September this year, are not helpful for the health of the streams. The sudden fast flow erodes the banks and causes flooding, for instance in Wadden, where the Bourne Brook overflowed in Cambridgeshire. It can also trigger excess discharge for the sewer plants as they try to deal with sudden increase in flow down the pipes leading to the plant. Extreme rainfall events lead to a lot of runoff because the soil simply isn't able to absorb the precipitation at the rate it's falling. In urban, suburban, and agricultural areas, this runoff will pick up pollutants from the landscape and carry them to nearby rivers and other waterways. Sadly, we probably have to accept that the combined effect of abstraction and climate change is going to affect our chalk streams. We therefore have to think of mitigation measures. For instance, tree planting on the river banks is a good climate change mitigation measure. However, Cam Valley Forum believes that there is also a need to have a different approach from the water companies and developers. If all developments were required to follow the standards set by the Eddington development to the west of Cambridge City, the situation would be much improved. This was designed with green roofs to absorb water, systems that capture all the grey water and filter it through local reed beds for reuse on site, and increased use of water butts for collecting rain runoff. Also, the implementation of SUDs, sustainable drainage systems for developments, would allow water to be naturally absorbed into the ground rather than being channeled by concrete carports and drives away from natural absorption. Ensuring full recycling for new sewage plants would also improve the quality of the chalk stream water. East Anglia, and hence the chalk streams, would also benefit from an extension of the north-south transfer of water into the region. Locally, high river flows should be captured in a new reservoir in the lower Cam Valley. Reduction of leakage would improve the available supply and would reduce the abstraction from chalk streams already affected by climate change impacts. You personally can help by reading the manifesto and lobbying your political representatives at all levels and responding to consultation on the local plan to ensure our chalk streams don't die, like a lot of the rest of our environment, under the pressure of increased development and continued activity that exacerbates climate change effects. You could also support the Cambridgeshire Doubling Nature project, which includes increasing wetlands. Ending on a humorous note, but with a serious message, I was recently sent a card with a picture of the globe exploding under the strain of climate change. The caption was, "Have you ever thought of turning it off and then on again?" Sadly, I think it will be another species that will be gradually turning it on again.